Hi, I'm Franklin Wang, and I'll be talking about my research into machine learning and asteroid detection. So to begin, a little bit about me. I'm Franklin Wang, a student from Palo Alto High School, and I've been working on research into applying machine learning to asteroid detection, and I won first place in the astronomy and physics category at the Regeneron International Science and Engineering Fair. Overall, the goals of this research are to use ZTF's publicly released data to look for asteroid streaks using a completely synthetic training set and a neural network approach. And these asteroid streaks correspond to asteroids moving fast enough to create trails in telescope exposures, and they are of significant interest since they tend to be very close to Earth. So to begin, let me talk about the overall methodology that I used. So for the data, I chose to use ZTF's public data releases, in part because I could compare my pipeline to the DeepStreaks pipeline which ZTF uses, but also since ZTF has released full nights of observation data, and also they have made their science, reference, and difference images available, which makes it much easier for someone like me to do research on transients. And so I take this data from ZTF's publicly released data, and I create a dataset of simulated asteroids for the positive samples. And I use a Gaussian point spread function model and simulate asteroids of different brightnesses, widths, and lengths, totaling to around 500,000 streaks in total. And so by using this purely synthetic dataset of streaks that targets fainter asteroid streaks, my goal is to allow for better detection completeness of fainter asteroids. And also any sort of transient that's not an asteroid is then used as a negative sample, and this includes artifacts like diffraction spikes or occurrences like satellites and noise. And so this dataset is used to train a convolutional neural network to differentiate between those two classes. In this work, I use a modified version of the EfficientNet B1 model, which is part of the EfficientNet model family and has a very high accuracy to computation ratio. And so finally, the neural network gets deployed, and here the differenced images from ZTF are used to find potential transients, and then the neural network looks for streaks among those transients. And I go through the positive streak detections afterwards to manually remove any false positives, and I get a set of discoveries. And so by training the neural network, I've been able to get the following results. Overall, the model is very accurate and works very well for detecting streaks. It has a very low false positive rate and also a high accuracy for the validation set. And below are some sample detections and also incorrect classifications. Overall, the model is quite robust, being able to deal with occlusions from other stars and also detecting some very faint asteroid streaks. Although there are some false positives due to various artifacts, but overall these are very minimal as there's an overall very low false positive rate. And so here are the new streaks that I've been able to detect. So in total, I found 6 streaking asteroids that ZTF has missed over the course of 4 nights of data from June 2019 from ZTF's data release. So all of these asteroid streaks do not match any known asteroids or any detections that ZTF has made. And I've also made multiple detections for each streaks to make sure that they belong to the same object. And I've also checked other possible sources of streaks, so to make sure these are not satellites, for instance. And overall, some of these asteroids are quite faint, and interestingly for asteroid number 6, I was able to get over 100 detections, and the model was also able to deal with a lot of occlusions from other stars. And for the second detection of asteroid 4, we see that the model is quite robust and is able to cope with discontinuities in the streak, for that streak. And so in addition to these new discoveries, I've also found detections of previously discovered asteroids. So based on the ZTF submissions to Minor Planet Center, it also seems that some of the streaks that I found have been missed by ZTF, although I do have some detections that I missed that ZTF did detect. Overall, though, I did have more detections than ZTF. And I've also generated rough approximations of the diameter and close approach distance of these asteroids to Earth. Overall, these asteroids are pretty small and also close to Earth, which is to be expected given that these are fast-moving asteroids which will have a close approach distance, and also since they're closer, they'll likely be smaller since they're at a close enough distance where they're bright enough to be visible. And so overall, using this approach, I've been able to find undiscovered asteroids using just a purely synthetic dataset and a machine learning model. And I hope to improve upon this by reducing the false positives even further, perhaps by automatically linking detections or finding ways to further remove artifacts. And I also hope to be able to apply this model to more recent data so that I can have asteroid confirmations. And one of the caveats with the asteroids that I've found is that since they're from data around 2 years ago, it's very difficult to get them confirmed and find new observations of them. So unfortunately, those are unconfirmed asteroids. And also, one of the major benefits of my approach is that it uses a purely synthetic data set, so no real streaks have to be collected, and this makes it easier to apply this approach to other observatories, and I hope to be able to do that and expand my algorithm by applying it to other observatories. Alright, thank you so much for listening to my talk.